Hello all, welcome to my channel. I'm back with a new video, and this video is part of the Iceberg series that we are doing. So let's get started. In this video, we will be discussing the two different table types which are present in Iceberg. The reason why there are two different table types, not table type, I will say these are update strategies. So why a table has two different state update strategy is because how we handle the updates. So Iceberg has a concept of immutable data files, so they generally don't, once the data file is written, it is not updated or touched again. Touch again in a transaction during maintenance it might, but in general during the transaction it is not touched upon. So how do we include or how do Iceberg handles the updates or deletes? So for that they have the concept of copy on write and merge on write. So in a nutshell, what copy and write does is that whenever a new update is arriving into the system, it will read the files which are affected and rewrite the whole with the newer changes in that, and it will point the metadata to the newer files. In case of merge on read, that doesn't happen. It doesn't rewrite the whole thing. It simply just logs or stores the new information. Let's say if it is a delete, it will say insert that in a delete file. And while reading, the data file and the delete file both are read, and then the output of those are merged. Merged in a sense, if let's say the delete file says that the row number 0 should be deleted, then while reading that data, those rows will be not considered in the output. So that is at the top level discussion. Let's see in slightly detail how things go. We will come back to this table, which is the summary, once we are done with this. So let's look at how copy on write works actually. So when an update or delete operation occurs, that what will happen is that entire data file containing the affected row is rewritten. That involves creating a new version of the data file with the updated and deleted record. So what happens is first the transaction identifies all the affected data files. For example, let's say if we say update certain row, so it will find out in which file that particular data is there. Okay, so it will identifies all the files. If it is, let's say we are doing multiple in the sense we are giving a condition where let's say something is negative. So all the places where those files are there, it will identify those files, and then they will scan those files fully and then rewrite it. But while rewriting that, they will include the updated data. Let's say we are setting the value to, let's say, from X to Y, so that the new file that will have the updated record. And once the rewriting is complete, the Iceberg's metadata points to the new snapshot of the updated files and removing the reference from the older one. So this is how copy on write works. But you see the challenge that we are rewriting the data. So let's say if a file size is, let's say we are using the default file size of 120 MB, although one single row needs to be updated, but the whole file is getting rewritten. So if you see, we will have more storage requirement for that, plus we will have to the update will be slower. Now copy and write, because it creates a new file and then updates the metadata pointing to it, it follows the atomicity and consistency. But new data is only available when the new write operation is completely done. So this ensures atomicity and consistency. And this is the picture, like for example, let's say there is a file which is affected. Let's say we are issuing an update command. So update is then going to happen in this file. So it will read this file and rewrite it with the new file name. It will have the content as well, and this file will get archived. Archived in a sense, it will be not pointing to the current snapshot. It will point to an older snapshot. Pros and cons of this. So it is very optimized for fast read, because the read time, there is no merging happening. The data is already updated, so read times are very fast. Guarantees a strong consistency, as we say, because the writes are only happening when the full commit is done. The cons are that we have to rewrite the whole file, so it's slow, and increased storage usage because we will create a new version of the file. Um, when updating a large number of rows, let's say if we have to anyhow, let's say we are doing an update in across the system, and if we have to anyhow update multiple places, then it is better to rewrite. So that in those cases, copy on write is an ideal solution. Let's see how merge on read works. So merge on read is something when a new record is up came or new record is getting deleted, so old existing record is getting deleted. What it does it will store the changes and in a separate file, and those are merged with the data files during the read time. So what happens is that if we have, let's say we want to delete a row from a particular file, so what will happen, it will create a delete file. It will mention the position or key based on which we are trying to delete, and then it will mention that okay, both of these files, when they are being read, these delete files will be merged with the data files. When it says that okay, whatever row or key by that we have mentioned, based on then it will say whether that row should be included in the output or not. So, and also an update is nothing but an delete plus insert. That's what how update is treated in Iceberg, MoR tables as well. So a delete record will be created, and a small new data file is also created containing just the updated record. So that's how this works. Pros, because we are only doing a small write, uh, it's writes are very faster, and because we are not rewriting the whole file, the storage also needed is less. But the cons is that while during the read we have to merge files. So if we have many delete files or delta files in there, in those cases, this read will be slow. And also managing these delta files is requires a lot of computation and for doing that merge compaction, and this requires a regular compaction, because otherwise the delete files or delta files will keep on growing, so we will have again the problem of small files. So yeah, this is for copy on sorry, merge on read. And as I was mentioning that we have two options, like either it can be a by position or it can be a by key, how we maintain a delete operation. So in case of positional delete file, we just store the file path, and in the sequence number, we say that okay, this positions row should be deleted. So that's how we store it in position delete file. And in the equality delete file, we mention the key constraint, like key based on which the delete was called. So we say that okay, these are the keys while you are reading the file. If you find a row with these satisfying keys, then you don't include that. Those are considered as deleted. So that's how these two different modes of MoR merge on read tables are there. Configuration, so we have option of setting configuration for these tables, update strategies. One is write delete mode, write update mode, and write merge mode. Uh, we can keep everything as one, or we can mix and match. So for example, for delete mode, we are using merge on read. For update mode, we are using copy and write. So yeah, these are the configuration, and this was what I wanted to discuss in this video. Let's see the summary. The summary wise, as we can see, copy on write versus merge on read. The write strategy is that copy on write will rewrite everything. The merge on read only creates a small delta or delete update files. Read performance is very fast for copy on write because the data is already fully compacted. In case of merge on read, it is slower because we will have to merge the delete files. Write performance in copy on write is slow because we have to, for a small change as well, we will have to write a lot of data. In case of merge on read, it is faster because we are only writing the changes which had happened. In case of storage impact, uh, the copy on write requires a higher storage because it has to store both the copies. In case of merge on read, it doesn't have much of an storage overhead because it only stores the small change that has happened. Update mechanism, the full file relight is on the update. In here, in merge on read, the updates are just rows written separately and old data is marked as deleted. And delete mechanism is full data full file rewrite on delete with removing the data that was there. In case of merge and read, we delete the deletes are tracked by in a separate delete files. As we have discussed, copy on write does not require compaction. It requires compaction for not for these purposes, but in general, we can say that we don't need a frequent compaction in copy on write. But in merge on read, we require a regular compaction because the changes, if the changes are happening frequently, those will keep on growing, and hence we need compaction to be done at a faster rate. Use case workloads with different read and infrequent updates will be good for copy and write. But in case if we have frequent updates that are happening and frequent reads are also happening, then merge on read should be the right approach. Suitability, read heavy workloads should follow copy and write, and analytics, bulk updates is good use case for copy on write. But let's say if we have update heavy systems, and let's say or we have streaming use cases in, or we are doing a lot of incremental update, then merge on read is the one that will be suitable for the use case. So yeah, this covers everything that we wanted with respect to copy on write and merge on read kind of update strategy. This was it for this video. Thanks for your time. Have a nice day.